In this lesson, we'll discuss learning target number 3. By the end, you should be able to predict the products and write the balanced chemical equation, including states, for synthesis and decomposition reactions. Remember that synthesis reactions are where two chemicals form one product. These two chemicals, A and X, could be single elements or they could be small compounds. There are 6 common patterns for synthesis reactions you are expected to memorize and be able to recognize and complete. Here are the general equations. The first pattern is, if you take a metal and burn it in oxygen, you'll get a metal oxide. If you take a nonmetal and burn it in oxygen, you will get a nonmetallic oxide. Pattern number 3 and 4 are the most common ones that students misrecognize. Pay particular attention to them. If you take a metal oxide and react it with water, then you get a metallic hydroxide, or a base. Pattern 4, if you take a non-metallic oxide and react it with water, then you'll create an acid. Pattern 5, metal plus nonmetal, produces ionic compound. And pattern 6, nonmetal plus nonmetal, produces a molecular compound, are more easily recognized. Here are some examples using the patterns showing synthesis reactions. Carbon plus oxygen. Let's write a balanced chemical equation, including states. Now this is a synthesis reaction. The only thing that I can do is take these two elements and join them together. Because carbon is a nonmetal and I'm burning it with oxygen, this is pattern number 2. A nonmetal plus oxygen gives me a nonmetal oxide. Now I could make carbon monoxide here, but let's go with carbon dioxide to make the equation easier. I'm balanced, and now I need to include my states. Try out the other examples and see how you do. Here are the answers. Sodium plus chlorine. This is a metal plus a nonmetal, so it's going to make an ionic compound, pattern number 5. In order to make an ionic compound, I need to follow the crisscross method. Sodium has a 1 plus, chlorine has a 1 minus, so I get the formula NaCl. I balance my equation and include my states. Because NaCl is in a synthesis reaction, it becomes solid because it's an ionic compound. Magnesium and oxygen. This is pattern number 1. I have a metal combining with oxygen. I'm going to make a metal oxide. Magnesium oxide is ionic, so I have to crisscross. Magnesium's got a 2 plus, oxygen's got a 2 minus. When I crisscross and reduce, I get MgO. I need to balance my equation and include my states. Magnesium oxide plus water. Magnesium oxide is an MgO. If I react that with water, this is going to be pattern number 3. A metal oxide plus water produces a base. I write down my metal, and bases have hydroxide ions. I crisscross my formula. If you check, my atoms are already balanced. I just need to include the states. Now, magnesium hydroxide is an ionic compound in a synthesis reaction, so our rule says that it should be solid. But because there's lots of water around in the reaction, that magnesium hydroxide could dissolve and be aqueous. Either answer would work for the state for magnesium hydroxide. It all depends on how much water is added. If extra water is added, then it's going to be aqueous. The next example is carbon dioxide and water. This is pattern number 4. I have a non-metal oxide in water. I'm going to create an acid. Acids always have hydrogens listed first in their formulas. Because there's oxygen in my reactants, I'm going to make an oxyacid. So I form a polyatomic with the rest of the elements. If I have a carbon and 3 oxygens, that gives me a carbonate, a CO3 with a 2- charge on it. If I crisscross that with my hydrogen 1+, I will get H2CO3 or carbonic acid. My equation's already balanced. Now I include states to complete the question. I run into the same problem with H2CO3 like I did in the last question. H2CO3, because it's an acid, it's considered ionic. So following our rules, it should be a solid. In real life though, if lots of water is added into this reaction, the carbonic acid is going to dissolve and ionize and be aqueous state. The last example is reacting phosphorus and chlorine. Remember, chlorine is a diatomic. This is a nonmetal plus a nonmetal makes a molecular compound. But there are a couple of possibilities, and sometimes it's not clear right away what the molecular compound would be. You might need to draw a Lewis dot diagram. It takes 3 chlorines to share electrons with phosphorus in order to make a stable compound. I need to balance my equation and include states. Because PCl3 is a molecular compound, you know the state through life experience. If you don't know, then you're allowed to ask your teacher. Remember, decomposition reactions involve single compounds breaking down into component parts or simpler compounds. That means the A and the X in this general equation could be elements by themselves or compounds. There are 6 common patterns for decomposition reactions you are required to recognize, complete, and have memorized for this course. Decomposition reactions usually happen in the presence of heat. Pattern number 1, metallic hydroxides or bases, when heated, decompose into metallic oxides and water. Pattern 2, acids, when heated, decompose into non-metallic oxides and water. You'll notice that pattern 1 and 2 are the opposites of the sum of the synthesis patterns that we just learned. Decomposition pattern number 3. Metallic carbonates fall apart into metallic oxides and carbon dioxide gas. Metallic chlorates decompose into metal chlorides and oxygen, and metallic nitrates decompose into metal nitrites and oxygen gas. Pattern number 6. Binary compounds, so compounds that contain two elements only, can decompose into their elements. Sometimes heat is used, but also electricity can be used to cause the decomposition. Let's use these 6 patterns to identify and write balanced chemical equations for the decompositions involving the following chemicals. First one, mercury 2 oxide. Using the crisscross method, the formula ends up being HgO. This is an ionic compound made of 2 elements. So I can decompose it using heat or electricity into mercury and oxygen gas. I need to balance my equation by putting a 2 and a 2 and include my states. Now HgO is an ionic compound in a decomp, so it will be a solid. Mercury is a liquid at room temperature based on the color code on our periodic table, and oxygen is a gas. Potassium chlorate. A chlorate is a ClO3 with a 1- charge. When I crisscross that with potassium, I get KClO3. This is decomposition pattern number 4. A metallic chlorate will decompose into a metal chloride. I crisscross this formula and get KCl, and it also produces oxygen gas. I need to balance this equation. I need to have 6 oxygens on each side, and a 2 in front of my KCl to balance the potassium and the chlorine. To finish the question, I include states. Sulfuric acid decomposing is an example of pattern number 2. Sulfuric acid has the formula H2SO4. Acids decompose into nonmetal oxides and water. If I take the 2 hydrogens and 1 oxygen away from the H2SO4, that leaves me sulfur trioxide left over. Sulfur trioxide is a gas, and H2SO4 is an acid considered ionic. In a decomposition reaction, it should be a solid. Calcium hydroxide decomposing is an example of pattern number 1. I have a metal hydroxide. It will decompose into a metal oxide, so I crisscross my calcium with an oxygen and get CaO, and water is my second product. My equation is balanced. Now I need to include states. Water is an example of pattern number 6. If we electrify water, it will decompose into its elements. Calcium carbonate decomposing is an example of pattern number 3. I have a metal carbonate. I crisscross the charges to get CaCO3. Metal carbonates decompose into metal oxides, so I join a calcium and an oxygen in crisscross, and carbon dioxide gas. My equation is balanced, and I include states. The last example is pattern number 5. I have a metal nitrate. It will decompose into a metal nitrite. So the NO3 turns into an NO2 and oxygen gas. My equation is already balanced, and I need to include states. Now, recognizing the 6 patterns for synthesis and 6 patterns for decomp might take you a little while. I suggest practicing the Brainscape flashcards for this learning target. We've got cards for each of the common patterns for synth and decomp. Once you have the patterns down, try out the homework questions listed on the schedule.